So the work for us in section 6.8 is twofold. Not only are you going to have to come up with the quadratic equation, then you're going to have to solve it. Now, one of the things you're going to face is working with expressions like consecutive integers. And let's give some examples in terms of positive integers. And that would be things like 1, and then 2, and then 3, and then 4, etc. But if you're way down on the list, say out here at x, what would the next consecutive integer be? Somebody said it? Not x. X plus 1, right? You're just adding 1 to get from one number to the next. That's how you're getting from, say, 4 to 5, or 5 to 6, 6 to 7, etc. So if you're at x, then the next consecutive integer is x plus 1. Sometimes that'll be modified a little bit. You could have consecutive even integers. So what would be some even integers? 2, 4, 6, 8, etc. Now, assuming you're at an even integer, where would I find the next even integer? X plus 2. Thank you. Let's do the same thing with consecutive odd integers. And it has a somewhat surprising result. So 1, 3, 5, 7, etc. Way down on the list, you'll find integer x. What will be the next odd integer? X plus 2 again, right? To get from one odd integer to the next, you're adding 2, just like you're doing for even integers. What's disturbing about that is like, well, wait a minute. I want an odd number here, but these odd integers are evenly spaced at 2 apart, just like they are for even integers. Yeah, okay. It's he's cast his vote. He doesn't like it. It'll be on Facebook later today. I don't like consecutive odd integers. That's all right. So it is a little bit disturbing. I mean, most people want to say, oh, well, it should be x plus 3, right? I mean, because that's an odd integer. But these are spaced a distance of 2 apart, just like these are. Where would you use that? Well, I'll make my history colleague Mike Volbach proud. We'll give you a little history lesson. So, the first state to enter the Union was Delaware. So, the 50th state was what? Anyone? Hawaii, yeah. Go there if you get a chance. If you number the states by the order in which they entered, then Kentucky and Vermont entered the Union consecutively. And the product of those two numbers is 210. So we have Kentucky and Vermont. Do we know when Kentucky entered the Union? What number it was? I sure don't. So let's call that X. If that's X, what should I write for Vermont when it entered the Union? Entered next, right? So X plus 1. So this is when it entered the Union. This is when Vermont entered the Union. The product of these things is 210. Okay, nice. What should I put on the left-hand side of this equation? Anyone? Not plus. X times X plus 1. So the product of those two numbers is 210. Basically, you've got the product of consecutive integers is 210. And that gives you your quadratic equation. Let's see if we can solve it. What would you do to solve here? Any suggestions? Well, the problem gives you the 210. Yeah, distribute. X squared plus x equals 210. That's a good start. What could I do from there? What should you do from there? You need a 0 on one side. So I'm going to move that 210 to the left-hand side by subtracting. When it changes sides, it changes signs. So moving over here, negative 210. Almost done. Just a little bit left. How do I solve something like this? It's a quadratic equation. Factor it. Absolutely. So I'll start you out here. Big help, right? X and an X. Woohoo. Well, we can do a little bit better than that, right? This number is negative, so one of them has to be negative and the other has to be positive. They have to have opposite signs so that you get a negative product. So it's a little bit more help. And the numbers here are a little bit challenging, so I'm not going to beat you up on it too much. Two numbers that multiply to 210 that are close to each other would be 14 and 15. But I need you to tell me which one is which. Which one's the positive one, which one's the negative one? 15 has to be positive. This sign has to be the sign of the larger number. So 15 and a minus 14. Well, we still have to finish solving here, but can someone read off my solutions here? X equals 14 and x equals negative 15. Could Kentucky have been the negative 15th state to enter the Union? No, that doesn't really make sense. All right. So Kentucky was the 14th. 14th. What was Vermont? 15th. So you have x was 14 and x plus 1 is 15. Yay, 14th and 15th. How are we looking on 26? Carly? Yes, when you go from here to here, you are changing the signs. Did I mix these up? Oh, you're right. Yeah. I didn't read it carefully. Kentucky entered right after Vermont. So, hey, nothing wrong with rewriting history. Our politicians do it all the time. No, I never said that. So, all right. LeBaron? No, okay. All right. Let's keep going then. A couple more here. Problem number 20 is a shuffleboard problem. The area of a numbered triangle on a shuffleboard court is 27 feet squared. Its height is 3 feet more than the base. Find the length of the base and the height. So, I'll tell you what. Let me draw this for ourselves. So here and here. Now the height will be this vertical line, the length of this vertical line running down from the top. And then this is the base. They tell us some things about this. This is problem number 20. Its height is 3 feet more than the length of its base. We don't know how long either of these is, but they tell you about the length of its height in terms of the base. So I don't know what this is, the length of the base. What letter do you want to use for it? You want to use B or do you want to use X? X? That was definitive. Use an X. Now let's come up with an expression for the height. The height is 3 feet more than the length of the base. Wait, let me just read that. Let me just double check it. Its height is 3 feet more than the length of the base. So what could I put here? X plus 3. All right. The formula for the area of a triangle. Does anyone know what that is? Good. 1/2 base times height. Let's see what we can fill this in with. See if we can get anything helpful out of all this. So the problem itself tells us that the area of this thing was 27 square feet. So let's put in the 27 for A. Equals 1/2 the base, which is X. What should I put in for the height? X plus 3. Do you see how we put that equation together? We first gave ourselves a nice picture, and then using this equation, we substituted in the things that we knew. We were given the area, given the base, and given how the height relates to the base. A lot of you would probably be unhappy working with an equation like this. What's one thing about this that you don't like? Fraction. Can we do something about the fraction? Well, it is 0.5, but is there a way I can get rid of the fraction so I don't have to deal with it? Yeah, multiply everything by 2. So if I put in times 2 here, times 2 here, on the left-hand side I get 54. On the right-hand side, 2 times 1/2, that's just annihilate itself. 2 times 1/2 is 1, times x plus 3. That's looking a little bit better. Liam, what should I do next? All right, so we'll distribute x squared plus 3x. And then what else were you going to suggest? Good. X squared plus 3x minus 54. So you got a nice quadratic equation. We're going to solve this by factoring. You can start out with an x and an x. Shane, what can you tell me about the signs that have to go here? Good. One positive and one negative. If this last term is negative, these have to have opposite signs. I need two numbers that multiply to negative 54 and add to positive 3. Robert? Good. Which one's positive? Good. 9 and 6. Well done. Thanks, gentlemen. Roy, can you read off my solutions here? Or my possible solutions? Ed, some help? Good. X is 6 or X is negative 9. Does it make sense that the length of your shuffleboard court is negative 9 feet? No. So we can throw that one out. So really the only solution is the base is 6 feet. What's the height? Where'd you get 9? It's right, but just tell everybody, where'd you get 9? X plus 3. 6 plus 3 is 9 feet. If you actually Took time to calculate the area here. 6 times 9 is 54. Times 1/2 would be 27. So it checks. How are we looking on 20? All right there? Okay. Let's try problem number 14. Kind of one last one here. It's going to be very similar to the one we just did. Oops. Let me do something here first. There we go. All right. Pool tables are rectangular and their width, their length is twice their width. Find the dimensions of a pool table if it occupies 50 square feet of floor space. That's a big pool table. It's a really big pool table. Okay. So here's your pool table, and it tells us that the length is twice the width. So I'll let the width equal x. What should this side equal? 2x. So the width is, the length is twice the width. How do you find the area of a rectangle? Length times width. L times W. See if you can't fill in some of the information here. So kind of another brief look at this one. Length is twice the width. Find the dimension of the pool table if it occupies 50 square feet of floor space. So try and fill in the formula as much as you can. You should get a quadratic equation that you can solve. So let's see if I can't squeeze this up here. So that's what we've got right there. Area equals length times width. Try and fill in some things here. Maddie, any suggestions? What can I fill in here? Good. X times 2x. That's not too bad. On the right-hand side, I get 2x squared. On the left-hand side, I get 50. There's other ways to solve our quadratic equations here. If you want to divide by 2 and take the square root on both sides, that's great. We're going to do that kind of stuff later. Let me remind you about how to factor these things. And this has a good little extra side benefit in terms of working this problem out. I'm going to move the 50 to the other side where it changes signs. If I'm going to continue factoring this, how does this factor? What should I try? Two times x squared minus 25. Wouldn't be an x, right? Because there's no x that's in common to both of those. So it's just a 2. Can this factor any further? Okay, how? James? X minus 5 and x plus 5. Now all that multiplies together and gives me a 0. Well, let's look at this. This times this equals 0. Where could x plus 5 equal 0? At what value for x? Negative 5. When does x minus 5 equal 0? Thank you, positive 5. Can 2 equal 0? No. So there's no solution here. That constant out front doesn't matter. It could be 2 or 2 million. You're still going to get that this isn't going to contribute to the solution. Now, can a billiard table be negative 5 feet wide? No. Trash that one. So it's 5 feet wide. How long? 10 feet. So the width equals 5 feet and the length equals 10 feet. 5 times 10, that's 50. That's your 50 square feet. Okay. I think that's it for this section. I'm not going to assign much in the way of homework. There is another set of videos or another video for this section online, so if you want to check that out for more practice. Try homework problems 11 through 15, 21, 23, 27, 35, and 37. That's section 6.8.